Hi everyone, and welcome to our talk on serverless Java in the cloud. So today, me and Rustam are going to talk about Microprofile, Quarkus, and Google Cloud Run and combine them. So this is going to be a fun 45 minutes. We're looking forward to this. I guess we can start by introducing ourselves. My name is Mats Opheim. I work in a technology company called Kubernetes, primarily with Java and Kotlin. And it's great to be back at JCON. So I was at JCON two years ago, had lots of fun, so it's great to be back.
Yeah, and my name is Rustam. I also work at the same company together with Mats, mostly with Java and cloud and all the architecture and things around all of those technologies. And this is my first time at this conference, so it's really great to be here. So thank you for having me. And I think that's enough of introduction. Well, I can also mention that I'm also a Google developer expert for cloud and a Java champion. But yeah, let's get onto the topic of this talk. You want to do the introductions, or you want me starting with Mats?
Yeah, I can start and you can
go ahead.
So the entire point of this talk is that sometimes, often you have the idea that I want to write some code, and you want someone else to be able to run that code, right? Mm-hmm. Probably on the internet. So I write some business logic to solve a problem I have, and then what do I do then in order to make you able to run it? That's kind of the main story of the talk.
Yeah, and also it's something about like showing the whole infrastructure, because most of you have written code, you've put it onto servers, and you've made it run and serve it to your customers, your clients, or whatever that might be, right? But we want to show you kind of a bit more streamlined version of what sometimes is being called for app modernization, or how you can put your Java code into something fast and make it really nice and smooth in the whole kind of pipeline of the whole thing. So the idea is that we have we needed some kind of application. So we started with this very simple application that would read two different dictionaries of words and return you a tuple. So basically two words, one adjective and one noun put together. So this was a little bit inspired by some authentication solutions that usually use this kind of thing, that they would use a noun and an adjective together to confirm that this request is actually coming from this thing. Or sometimes they use it for, I don't know, naming containers and things like that. So it's basically a very, very simple on purpose application, because we wanted to keep the logic very simple. So the idea is it would just, you go to a URL. As you can see, this is a local host on purpose for now. And it would just give you a two-word tuple thing. And well, there are several versions of that, right? So it's just basically every time you return refresh, it will return you a random noun and a random adjective.
Yeah, so that's kind of where we start with. Okay, this is what we want. So if we head on to look at like the first step in order to like get this code in production, well, the first part is actually writing your logic. And as Rustam has already been talking about, like the logic here is kind of simple. This is like the most logic-filled part of the application. It's like, well, you get random adjective and you get random noun, and that's pretty much all there is. So we had some fun and added like you can read from a file or from an enum with a list of adjectives, but just Java.
Yeah, and again, I mean, we did that on purpose. So we needed something very simple. In your case, there would be something much more advanced, probably. But you know, with microservices, it's kind of keeping things very simple and everything. But anyway, you have a logic, right? So you write your logic, but now you want to put your logic on something that can execute that logic for you, preferably on demand, right? So that comes where the second step of this pipeline would be, where most of us have been there. Well, you need to run it, right? You need to have something. I mean, you've written it in your IDE or any kind of other whatever you're using to write your code. But then just pushing the play button in that IDE doesn't really help. You need to run it on something. And then to run it, we looked at several possibilities there, and we needed something lightweight and nice and quick and things like that. And that's where the MicroProfile kind of came in. So usually we've done a few other talks on MicroProfile, and but every time we ask people, well, it's a little bit hard to do that in the virtual environment, but in like in in-person kind of conferences, when we ask people to raise their hands and explain, tell us if they've heard or used MicroProfile, it's not that many. So probably we'll spend a little bit of time explaining why we ended up using this kind of as a platform to run our code and to develop our things on top of that, right? Because logic is just one part. Now you need to make it consumable in some kind of way. So you need to create some kind of web service or maybe something else. So in our case, it's a web service. But I guess we should spend a little bit of time saying, what is that thing?
Yeah, probably, because I guess many, as Rustam said, probably not all of you have been looking into MicroProfile so far. And well, MicroProfile, to put it easily, it's similar to Jakarta EE for microservices. So you have a lot of different standards or specifications that are put together into, say, a package. So like Jakarta EE is a package of many different things, been going on for many years. But after a while, like a couple of years ago, quite a few of the app server developing teams figured out that, oh, for microservice, Jakarta EE is not really that suitable. It's like, on some fields, it's kind of overkill and has lots of functionality that's really useful if you're developing a monolith or something kind of monolithic. But if you're writing microservices, then you need some other specifications.
Yeah, and it's a kind of handy. Well, I mean, if you think of it, right, you want to build something. You want to build a house, or even more, something very simple, a shed, right? But then you need a set of tools that will help you to build that thing. And think of this as this kind of set of tools that will help you to build all those things around it. Because as you can see here, this is the latest. Well, it's version 3.3 of MicroProfile, and you can see the packages that it follows with it. And you'll see, I mean, most of the cases, there are things that you probably have seen before. Some of them are from Jakarta EE, some of them are not. Some of them are were made specifically for this kind of microservice architecture kind of things. And there is a lot of, well, there are some other goodies outside the MicroProfile kind of umbrella, which are also connected, but not yet a part of the MicroProfile. So we've mentioned those as well, but look mostly at the packages that you will see in this bigger square in the middle there.
Yeah, and I guess it's worth adding as well that, well, so several of these specifications are tailored really for running on Kubernetes or like adhering to cloud native ways of doing things. So things like the health, for instance, it gives you a liveness probe and a readiness probe, exactly the same format that Kubernetes wants. The config specification can easily be combined with config maps in Kubernetes and so on. So MicroProfile also has this, well, they say that it's opinionated, in the sense that you can see that it supports JAX-RS, but not JAX-VS, for instance. So it's like tailored towards running, well, APIs with kind of restful, or kind of restful at least. So it's like there's an underlying idea in MicroProfile that this is the way we do things, in microservices nowadays.
And well, that's one of these things was obviously that it was very simple to build microservices with it. The other thing was that also that it is supported by quite a lot of different companies, and it's It's quite a big variety of those companies. I mean, there are some very big and known ones, and there are smaller. There are some Java user groups, so like London Java community and Atlanta Jug, and so you'll see like this kind of a little bit smaller, so Java, a little smaller community like entities, or you will also see like big companies like Microsoft or Oracle or IBM or all the others. And yeah, and it's pretty cool because quite a few of those bigger names would have their own app servers that would let you run code that was written with Microprofile as well. I guess we should spend a little bit of time also saying, we did talk a little bit about why, right?
Yeah,
but there are some other things, because like still, I mean, we have a few answers to this why question. And as you'll see, those answers will, I mean, they fit perfectly well, and we originally wrote them for Microprofile, but then we realized that all those answers would actually fit into the whole idea of this pipeline, or the whole kind of ecosystem that we were building with this talk. So one of the first things is that you don't really have to do all this boilerplate code writing because, well, I don't know, things like handling configurations, or handling REST requests, or even having a REST client to communicate with another REST service and things like that. That's a lot of work if you have to write it from scratch, and you don't, most of the cases you don't want to do that. So one of the things is that, well, there is not that much boilerplate code. You just usually do a lot of annotation style kind of things. And actually another thing that we usually mention when we explain Microprofile is that it's also very similar to Jakarta-E in that sense that, the idea is the same. I mean, if you're used to working with it, you can just do like add something with annotations and do things like that. It will be more or less the same way of doing here as well with Microprofile. Anything else should we mention, or should we go to the next slide?
I think we can head on.
Yeah, well, another one, also a little bit kind of obvious thing that you would expect with microservices is that it's lightweight. So it's quite easy to run. It goes fast, and it also, another thing that usually you mention, Mats, is that it's a specification and not an implementation, right?
Yeah.
So that lightweightness probably should be credited more or less to those who actually implement it. But still, I mean, in most of the cases, it is a very, very lightweight. It will be the small variations of startup times and stuff like that, depending on the implementation. But most of the times, it will be really quick.
Yeah, and like in addition to that is that, well, your code, like the application binary that you tend to write, you end up writing tends to be a really small class, while most of the boilerplate code is in Microprofile, which is part of your app server, and then, well, it's not part of your binary, so your code will be more lightweight as well.
Yeah, and the other thing is also, and well, again, all those things that we mentioned now, it's going to be applied to all the other parts of our parts of our pipeline. But the other thing that we should probably mention is that it's also interchangeable, and by that we mean that you can easily, with very, very few lines of code, or even just POM file config in most of the cases, you will be able to switch between app servers. So you can just run your stuff on, say, Tommy, and then one day you want to try it to run on Open Liberty, or if you run your stuff on Open Liberty and you want to switch to something else to try out how it works on the other one, it's very easy. It's quite easy and quick change to move that around. Yeah, I think that's,
and there's also a principle, like underlying principle in both Microprofile and Jakarta-E, that the same application, you can take the same application binary and deploy it to your app service of choice without having to change the code at all, and it should just work. Often it does.
So yeah, and then probably I mean, we kind of allow us to advertise a little bit for that thing because it's an open source initiative, and nobody is getting really any money for this kind of thing and anything. So that's why we kind of put one little slide like, okay, what this thing is kind of cool. So where do I start? And well, I guess the good starting point would be to try the starter. It's very similar to like Spring Starter kind of, or the other. I mean, it's getting very popular with this kind of starter page, right? So yeah, the URL is there, and just go ahead and try it if you want. You can just generate an artifact, and then you can just do changes within it, and we'll have some examples and things.
Yes, and you can choose which examples you want. So if you know how health works, okay, then you don't want that example. But I'm a bit unsure about JAXRS. Okay, I add the JAXRS example. And you can also say here that I don't want the newest version of Microprofile. If you, for some instance, for some reason don't want to do that, or well, you can choose your runtime or Java version. Yeah, you see that. You see it all here, and then whenever you press download, you get a zip file or something with the POM file and the config files and everything you need to run your application.
Yep. So yeah, okay. Now I want you to think of what we're going to talk about as a kind of a strange version of Maslow hierarchy of needs, right? You have this pyramid of the basic needs, and then it gets more and more advanced and kind of a bit more fancy things on top. So at the bottom, you have your code. On top of that, you need to have something that will execute. So that's kind of the basic, the basic need that you might have, right? To write your logic. Without that, nothing happens. So on top of that, there will be something that executes and makes it possible to easily kind of add all these things that would otherwise be boilerplate kind of thing. So in this case, in our case, it's Microprofile. So now it works on my machine, and it kind of serves this local host thing. As you saw in the beginning in the examples, we purposefully put there like http://localhost there. So now it actually runs on my machine, right? Now what?
Yeah, so, and no.
Yeah.
Yeah, and like developers have been asking this question for many years, and suddenly someone said, "Well, it works on my machine. Okay, so let's ship your machine then."
Yeah, exactly. Because I mean, that's the problem, right? Because it works on my machine, but doesn't really have to necessarily work on the other machines. So at some point, some years back, they found at least one of the solutions to that. It's to kind of standardize your machine in quotes. So we put it into a container. So in this case, we use Docker, but well, obviously the Docker is one of the implementations. But yeah, let's stick with Docker for now. So how do we do that? You create a Docker file, right? And there are a few things that we can mention. I don't know if should we mention it now?
Yeah, I think we can mention. I think we can start by saying that one positive, one advantage of using Docker in this context is that, well, many of the app servers and the download you saw on the previous slides will give you a Docker file, like included, so you don't have to do anything, or you can, well, adapt it to your needs, but you have the basic Docker file there from your app server in many cases.
Yeah, and then that's also things to consider. Is like, I mean, we put it again on a very, very purposefully with very fine print. Those things that we put there is that because most of you have probably done this. Most of you probably have Dockerized your applications. If not, you have at least read about that or heard about that. So you know things to kind of not to do or to do and things like that. But we can we'll still mention it that you know, as a reminder. So, you know, small footprint and, you know, things like multi-stage build is a very important thing. And it will also help us throughout this kind of this talk as well. So this is, I think, kind of felt that it was important to mention that anyway. It's multi-stage build is really, really nice things, because otherwise you will end up with a huge monster containers, very, very full of things that you will never use after the build stage is done, for example, things like that. But now, okay, now you've put it on your machine, it works, you put it into a container that kind of should make it work on many different machines. So now you're kind of moving further up in this kind of hierarchy of needs. Now you want to make it available for everyone. You can obviously put it on your own servers and let it run there. But, you know, since we're talking about this app modernization and all these kind of things, we want to do something a bit more smooth than that, because you don't want to do a lot of management of all that. You don't want to spend a lot of time making your code work and making your servers like restarting and, you know, all those kind of things. So you probably have guessed where it's going. So you put it to the cloud. And it doesn't really matter what cloud you put it on, but, you know, containers run on mostly any kind of cloud. In our case, we used Google Cloud, but it doesn't really matter. I mean, all those kind of things can be done on other platforms as well. The reason we chose that is like, well, it's probably the thing that we've used most, but it also has a few nice open source, well, managed versions of open source tools that we'll see also in a second. So now you want to put your code into the cloud, but to put it just simply there, it does not really help you with a lot of things. So first of the things that you really need to do is to automate your builds. And by automating your builds, you are actually making it possible to just create, you know, all those things that used to be called continuous integration, continuous CI/CD pipelines. Later, it kind of evolved to a more of a culture where you do the DevOps things and where you expect everything to be automated as much as possible. And so you might automate for many reasons, but, you know, in most of the cases, you want to automate that. And in this case, you can also do that we did that in Cloud Build. And, well, a little spoiler alert is that we have all the code and everything on that. We'll share the link with you, and where you can actually have a look at this kind of thing. So we built it originally with a workshop in mind, and then this is kind of the condensed version of that. So all of those things that you see, the reason you see the examples there is that actually there is a real code behind it as well.
Yeah, so I guess we should come back next year and do the workshop.
Yeah, that would be fun, actually. That would be quite fun. Workshops in person, that still is the thing. It's virtually, it's a bit more tough, I guess. But yeah. Okay, so
I think it's worth mentioning here though that you can see under the event part here, you can see repository event that triggers. Okay, that's pushed to a branch, and that's, as a developer, that's what I want. Right, I want, whenever I do git push, I want the newest code to be built and be available somewhere.
Yeah, and then you just don't have to, again, I mean, if you remember back to those things that we were mentioning, interchangeable, well, it still applies because you have Docker containers, you can just move them around as much as you want, but also you make it also very portable in a way that you can just build a new version and it will be just available there, and you can just use it immediately almost, and that's a very nice thing, right? So how do you do that on the cloud? So, well, you have two options. You have this good old friend called Dockerfile, or you can do a little bit more specific for your build system. So in our case, it's cloudbuild.yaml. But yeah, it's somehow similar to what Jenkins is. Well, I mean, it's the same idea of the Jenkins build files, isn't it? Yeah.
Yeah.
So yeah, okay. So now we came to this kind of cloud thing. So now we put it into a container. We automated the builds. We have everything just happening automatically and deployed, right? So now we put it there. So what do we do now? What do we want to do now? Because we still need to have something that can serve our requests, and we also want, well, obviously you can just create a virtual machine, but if you do a virtual machine, this is not the cloud native way of doing that, because you don't want to go and manage that machine all the time. And if amount of requests go up or down, you don't want it to scale up or down your machine and do all those kind of things that will still remove this joy of being a developer. So now we're moving a little bit. So now we have cloud. So now we have a little bit more fancy, we're moving up on the hierarchy of needs, I guess, and the cloud needs. I know we should probably come up with some kind of fun name for this hierarchy. Anyway, so now we do what we do now. We put things to serverless, and by serverless, so as you probably know, it doesn't really mean that there are no servers. It means that you don't have to manage it, or well, minimize the management of it anyway.
Yeah, like the servers aren't your problem anymore. Like you're less of the problem with the server.
So now we kind of continue our, well, I don't know, call it parade of open source tools. So now we're actually still we're still on, even though we're on the cloud, we're still on the open source kind of thing, because what we want to introduce now is something called CloudRun, as you probably have seen from the title of this talk as well. But CloudRun is a managed version of Knative. And Knative is an open source thing that you can just basically install wherever you want and just use it as you wish. Well, CloudRun is the managed version, and it has like two flavors of that. So one of them is like fully cloud managed version, and the other one is called CloudRun for Anthos, which lets you have very specific containers. So it would let you have if you, for example, need very specific hardware requirements for your stuff, you can also put, you can use that version of CloudRun as well. So then, for example, you have some kind of service that uses a lot of TPUs or GPUs or things like that, and you don't want to put it on the cloud, or for any kind of reason that you don't want to use this specifically, like the cloud-made generic version, you can also use your own, and it will also let you have Kubernetes, because it's built on top of Kubernetes. It can let you have a hybrid Kubernetes clusters that are partially running on the cloud and partially running on your machine and things like that. So it's a very nice thing. But again, Knative, you're still on the open source thing. So you can just basically install it still on your machine and it will work. And the cool thing is that it will also do all this scaling. So you can do, you can define the minimum number of machines, maximum number of machines. It will scale up and down depending on traffic or depending on metrics and things like that. And it's really, really nice kind of way of reducing this overhead, I guess, of managing services.
So this is what CloudRun looks like the dashboard you can see in CloudRun. So it's like typical Google Cloud style, but you can see, like on the left hand, you can see, well, our builds and typical CI/CD style. There are lots of failing builds, and then there's suddenly a working one.
That's how it happens when you develop a demo for a talk, isn't it? It's like, oh, it works.
Yeah, like all those endless commit lines with like CI/CD, please work now, and like all of this.
It should work now, I promise. Well, that's.
And you can also see, yeah, and you can also see things like memory allocated, which you can adjust. You can say that I want to give this CloudRun service 1 gigabyte of memory or 4 gigabytes, or yes, in our case, 512 megabytes or whatever. Also, you can customize.
And one more thing that probably is worth mentioning is this the managed traffic. I don't know if you can see this little link on top there, but you can basically manage traffic, so you can route some of the traffic to a new. So you can deploy a new version of your service, and you can still keep your old one, and then you can actually redirect some of your traffic to the new one and keep some of it to the old one, and then so that means that you don't really have to just do big bang deployment for all users. So you can just redirect small amount of users, test, see if it works, let it run for some time and collect all the errors and bugs and stuff, and then you can decide if your new version is good enough to be to take over for the old one, or you can you should kind of roll back or redirect the rest to the old service and fix some things in the new one and things like that. So you can do a lot of testing and like A/B testing and red, green, and all those kind of different deployment strategies that you might use for this kind of stuff. Yeah, so I guess now we are here, right? So now you can see that. So now there is no local host anymore. So now we're actually on the cloud. It runs on with a in a container. So it's running with Microprofile and it's managed by cloud thing. So and it still returns me things what do we want, like this tuple of 2 words. We talked a lot about serverless, and we talked about a lot of good things about serverless, and that's how it is. But there's not always just like fantastic kind of good things about it. So there are some things that probably we need to mention where you might not want to go serverless, because serverless means that it will be able to spin up and down your application depending on traffic. So you might want, for instance, with serverless, want to spin down your application down to 0 and nothing at all. And well, so if your application does not support that, if your application does not have this stateless kind of architecture, you won't be able to do that, right? So this is the things that's where you should consider something else than going serverless. And like using CloudRun or Knative or any other kind of things that will provide you this, right? Another thing is, yeah, go ahead.
Yeah, I guess you also can say that, well, but my application takes 10 minutes to start, which may be the case for some old legacy applications. Yeah. And then, well, you don't want your user to wait for 10 minutes for every request, and then probably serverless isn't suitable. So another way to say that is that, well, with serverless, your application should be able to start really fast. Like every second of startup time is a second that your user probably will have to wait.
Yeah, and that's actually a very, very good point, because we did jump over one of those steps in this hierarchy of needs things. Somewhere between serverless and cloud, probably, there is this step of making things fast. And that's quite an important point, because, well, I mean, it's a microservice. You want to deploy them often, and you want to deploy them many, many times a day, an hour, a minute, I don't know, depending on what your needs are. But to be able to do that, they need to boot up fast. And the thing is that, well, runtimes that you're using, or like things that you're running your code on, they will differ. So they're all like a snowflake. They're all unique, and they will have their own kind of boot up times and requirements and things like that. And that brings us to another open source kind of tool, or framework, I guess. It's probably a good word for that.
I guess we can name it framework, because, well, exactly the same way as Jakarta has lots of implementations, so has Microprofile. So we've already mentioned some of them, like OpenLiberty from IBM, or Apache Tommy from Tommy Tribe, Cumulus EE from Slovenia, nice little app server. So there are lots of alternatives you can use, which, well, each of them has their own strengths and weaknesses and focus areas.
And most of them would be, I guess, called an app server. But there is one that is a little bit more than that, or it's more of like a framework and stuff like that. And that's, as you probably have guessed, that's the one that we haven't mentioned when we were listing all these things. That's also, it's another open source tool that was made by Red Hat and released, what was that? It wasn't that long ago, a year ago or so, wasn't it?
Yes. Last year sometime.
Yeah. So and that's Quarkus, and that's the kind of thing that makes it even make things even faster, and the boot up times are insanely different. I mean, it's like it's super fast. It's not just a marketing thing when they say supersonic Java. It actually is. So what we did was actually to put everything, like package our Microprofile little app onto Quarkus, put it into the container, put it into the cloud, make it manage itself or kind of automatically managed, and just like offer that as a service. And that's a really, really cool kind of parade of all these open source tools that you can technically put anywhere, really.
Yeah, I think there are some things you should mention about Quarkus.
Yeah.
Yeah, time is running fast, but I quickly can say that the idea of Quarkus in a way is that it's meant to be running a container. So it's like, you can say cloud native, they say Kubernetes native. And by running an application in a container, you can take some of the, so to say, prerequisites of Java applications, and like some of the setting has changed a bit. So like the ability to be able to scan for CDI beans at runtime, for instance, is not as important. Probably not that important anymore if you're actually running in a container, because in a container you know a lot about your application, your runtime, like everything during compile time. So instead of doing so much reflection and things runtime, they're trying with purpose to move most of the logic and like most of these things into the compile time, so runtime gets faster.
Yeah, and also it's it also does a lot of things for you. It helps you with creating those images and like Docker files and stuff like that. And depending on what, if you go JVM or the native mode and all these things, we don't have time to spend a lot on this right now, but we will kind of leave it to you as a little bit of a taste to explore more. There's a lot of good talks by really, really nice and good people from most of them are working for Red Hat, but I mean, again, it's an open source thing, so just it's open for everyone. But there's a lot of good talks explaining how Quarkus works and why it's so fast, and it's really, really amazing thing. So we did on purpose, again, we kind of kept this thing of making it super fast to the end, because it's in our pyramid of needs, it's probably somewhere in the middle, but we keep the good parts to the end, I guess. So now we actually, now it works. Now you run it and it's really fast, and you can just deploy new versions of that. And again, it's a very simple app, and the idea is to just show you this kind of path and things to consider when you create those new modern apps or modern web services or microservices, as you might want to call. And pretty much now you are done with everything, and everything works. And there is a lot of things to consider on the way. I mean, we just gave you the taste of the whole thing, but there is a lot of things on each step of that. There is a lot of things you can consider and dig much, much, much deeper into, and we'll be happy to discuss all those things with you. But we can do that during the questions and Q&A sessions. One last slide, or there is one more slide with thank you and everything, but this is the last slide with the link that I promised to GitHub, where all the code and our example lives. And
our cloud build YAML file, so you can, you don't have to do the same CI mistakes as we did, and just copy sample request if you would like to improve something, but everything we've been talking about is there.
Yeah, and so that is the link, and this is us on Twitter. So feel free to ping us there. Follow, ping, send us messages, send us questions, or anything like that. And I think now we should let you folks ask us questions. Are there any questions?
So I just post a link in the chat as well to the GitHub. So
sounds good. Perfect.
For the strange formatting, there it is.
So I'm not sure how you do this the questions. Do you want to type your questions, or are you able to unmute yourselves and ask the questions? I'm not sure what's the preferred way of doing that, but I guess you can do both. Yeah, both is possible. So yeah, if you wanted to ask them in person, please unmute yourself now and ask. And if not, then I can read them aloud.
Yeah,
that's
yeah, that's a great question. Well,
I guess we should read it aloud. I'll read it, you'll answer it. Or well, you know. So the question is, any comments why MicroProfile versus Spring or Quarkus versus Micronauts? That keeps on popping up all the time.
Yeah, now but I can try to answer the first one. And first of all, both MicroProfile and Spring are great alternatives. The same with Quarkus and Micronauts. So MicroProfile, like one of the benefits of MicroProfile is that it's a standard. So there are several implementations, so you can switch app servers if you want to. So like if there's something in your app server that you don't really like, you can switch to another one. So like with Spring is more like standard implementation combined. And another advantage of MicroProfile is that as we spoke about a bit about Jakarta E, like the CDI is the same, the JXRS standard specification is the same. So, and also the JSON parsing part is the same specification. So if you know Jakarta E already, then you easily get to know MicroProfile. And also MicroProfile and Jakarta E can be combined. It's typically, the app servers typically support both of them, so you can pick and choose whatever suit you need.
Yeah, and so if you're used to one of them, or if you're used to Jakarta E, it will be easier for you to get started, I guess, with MicroProfile. But yeah, I mean, it's both are working and both are pretty good. We have not tried Micronauts with this setup yet. We probably will. I don't know. Maybe we'll try it at some point soon. Yeah, that's possible. The idea is to put it somewhere that will kind of give you this, let you not to write a lot of boilerplate code and just save you from that.
Yeah, I'm not really sure of whether I'm not that into Micronauts, so it might be that they also support this, but Quarkus also has this native mode, which lets you run Quarkus and with Java or Kotlin code outside of the JVM, which I think that's I guess that's really a new thing that it's built on top of a Graal VM. It's like they've been focusing a lot of making Quarkus run without the JVM, which of course makes it really fast, but it's not really suitable for everything.
Okay, so there is another question. What is the difference between the serverless approach with Kubernetes that you described compared to AWS Lambda? What are the use cases that do not fit into the AWS Lambda serverless approach?
Yeah.
I mean, yeah, you want to start, or you want me to start?
I can start.
Go ahead.
I don't really know AWS Lambda that well, but at least Google has this Google Cloud Function thing. I don't know if they're like the same, but with CloudRun, you can have several endpoints and it's like you run your application without having to do that much adaptations of your code. You just run your same application as you would on a regular Kubernetes. You run it on CloudRun, whereas if you were to run on Cloud Functions, you would have to change the signatures and change your code a bit.
Yeah, and I will put, so please comment on that if you don't agree, but I'll put all of those serverless functions things in one basket and just call them serverless functions, like AWS Lambdas and all the other ones. But basically, the usually thing with those is that they have a limited lifetime. So the requests cannot live longer than so and so long. Another thing that they would have typically maybe, I'm not sure about that, but I think they would, most of them would have a one endpoint or like very, and also they would all require a bit more specific. You need to write your code in a way that is supported for that particular platform. So you need to have like their own different libraries and things like that. I mean, we've seen the similar things before, even before this functions things were cool. You had this thing called App Engine that Google was started, which kind of, sometimes they call it as a first version of this kind of cloud serverless thing. And back then, you would need to also use specific libraries and stuff around it to be able to use it. And so you would have to have specific support for things. So with the kind of the approach that we used, it gives you pretty much much more freedom in respect with all this libraries and things that you want to pull into your application. So it will give you more flexibility. Functions are amazing and really, really good stuff for simple things. But if you do a bit more complicated logic, slightly a little bit more complicated logic than what we have shown, probably you will feel kind of a little bit of resistance when you just have to stick with cloud functions. And those are also a bit difficult to port around. So they're not as movable as easily as you would see with this container, whole thing packed in one big container, or well, hopefully small container. Yeah, you're welcome. Does Microprofile provide a service discovery mechanism? I think...
No, not really.
Yeah, no.
That's a long talk, but like, no, the service discovery part is typically on, say, the cloud vendor side. So like, for instance, in Istio or Kubernetes, like this is the service discovery part instead. So it's like, it's not part of the application as such, it's part of the infrastructure around it. I guess you can do some kind of Netflix-based service discovery thing, but yeah, it's not. No.
Usually, you will need to have something next to it that will do that. But then, yeah, usually it's the service mesh part that usually will handle this kind of things for you. So typically Istio or something like that, and the cool thing with Knative is that it kind of hides a lot of this kind of things for you if you don't have to think about it. So you do not have to set up Kubernetes cluster. You do not have to set up like this service mesh around it and things like that. It's kind of all is being done for you in a way. Thank you very much. Thank you for being with us.
Thank you all.